Hey everyone, here's our math problem for today. This is an Oxford algebra problem. Find the value of x and y given this system of radical equations. The first equation is the square root of x plus y all over 2 plus the square root of x minus y all over 3 equals 14. And our second equation is the square root of x plus y all over 8 minus the square root of x minus y over 12 equals 3. By just looking at the problem, we know this is a complicated radical equation. But later on, you will realize that this equation is really a beautiful system of radical equations. You can pause the video and see if you can solve this Oxford algebra problem. Now, let's solve this problem together. When you are solving for a radical equation, the first thing that you are looking at is the presence of perfect squares in the radicand. Notice that in the second equation, this 8 can be expressed as 4 times 2, and 4 is a perfect square. Similarly, this 12 can be written as 4 times 3, and 4 is also a perfect square. So, let's copy the first equation, but let's do a little change in equation number 2. We now write this denominator as 4 times 2, this 12 as 4 times 3. Now, since this 4 is in the denominator, if we are going to pull this outside this radical symbol, it's implied that there's a numerator of 1. And so, we are basically getting the square root of 1/4, which is equal to 1/2. The same thing here. And again, this is a system of equations taken simultaneously. Then let's observe. Notice that you have here the square root of x plus y over 2, and you have the same exact expression at the bottom, the square root of x plus y over 2. Similarly, you have here the square root of x minus y over 3, and that is also exactly this expression here, the square root of x minus y over 3. We can make this equation simpler if we are going to apply variable substitution. We let a be equal to the square root of x plus y over 2, and we let b be the square root of x minus y over 3. And from this substitution, we can now rewrite the given equation as a plus b equals 14 and 1/2 a minus 1/2 b equals 3. What we did is we substitute the square root of x plus y over 2 by a. So this one is also substituted by a. The square root of x minus y over 3 is our b. So we now have this b, and this one is also replaced by b. All the rest are just copied. And because of that, we now have a simpler equation to work with. Notice that we also have here a fraction, and the way to deal with fraction is to multiply the equation by the least common denominators. Here, the denominator is 2, so we multiply the equation by 2, and that will eliminate the denominator. So let's copy first a plus b equals 14, and distribute 2 to each of the terms here. So 2 times 1/2 is 1 times a is a. 2 times 1/2 again is 1 times b is b, copy the minus sign, and 2 times 3 is equal to 6. So these last two equations are equivalent to our original equation, with this as our substitution for a and for b. This is easier to solve using now elimination method. We add these two equations. So a plus a gives us 2a, 14 plus 6 equals 20, b plus negative b is 0, so we did not write the variable b anymore. And divide both sides by 2 to get a equals 10. Now to solve for b, let's take again the first equation, a plus b equals 14, but this time we now know that a is equal to 10, and so solving for b is 14 minus 10, or b is equal to 4. But this b is equal to this expression. This 10 is also equal to this radical expression. So let's put them together. So since a is equal to 10, we now form this equation. 10 is equal to the square root of x plus y over 2. Similarly here, since b is 4, we now substitute 4 for b to arrive at this equation. Now let's set aside this equation here, and let's work with the first equation. So solving now for x plus y here, we square both sides. So 10 squared becomes 100, and squaring this will eliminate the radical symbol, and so the right side becomes the radicand x plus y over 2. Multiply both sides by 2 to get 200 at the left side, and copy x plus y, and we are going to go back to this equation later on. Let's put this second equation back to our working area. We square both sides, this becomes 16, but by squaring the right side, we will eliminate the square root symbol. And so we have 16 equals the radicand x minus y over 3, and multiply both sides by 3 to get 48 at the left side, and at the right side what's left is x minus y. Again, we have here a system of equations in two unknowns that we can solve again by elimination method. So we add these two equations to arrive at 200 plus 48 equals 248, x plus x is 2x, y plus negative y is 0. So we did not write the variable y anymore. And solving for x is 248 over 2, or x is equal to 124. Then using again the same system of equations, this time we are going to subtract. So we can solve for y. 200 minus 48 is 152. X minus x is 0, but y minus negative y becomes y plus y, or 2y. Dividing by 2, we have y equals 76. And so we now have the values for x and y. X is 124 and y equals 76. To check if our answer is correct, let's substitute 124 for x, 76 for y, and using Desmos graphing calculator, it's verified that the first equation is indeed equal to 14 when these values for x and y are substituted to the given equation. Similarly, we verified that the second equation is indeed correct. The difference of these two radical expressions is 3 when x is 124 and y is 76. And so we are now confident that our final answer, x equals 124 and y equals 76, are the solutions to this system of radical equations. Thank you very much, and we hope to see you again in our next video. Bye for now.